Okay, grade 7, this is your 4.2 multiplying decimal numbers. In grade 5 and grade 6, you learned how to multiply 2-digit and 3-digit numbers. The extension here in grade 7 is simply doing the same algorithm, except this time you're dealing with decimals. So what the grade 7 curriculum wants you to be able to do is this word right here. They want you to be able to estimate the product of two numbers. And that's the important part. And to be honest, that's the most important part, because 95% of you or 99% of you all have calculators in your pocket at all times, right? Back when this textbook was written 15, 20 years ago, that wasn't the case. People didn't have access to calculators at all times. So you had to have an algorithm you needed to use to get the answer. Now, we still haven't kind of got up to date with the fact that we don't need you to have an algorithm, but we still make you do it because that's what the government says. But the estimation, in my opinion, is the most important part. So if I said, excuse me, 194 people gave you $4.49, approximately how much is that? You should be able to say, I'm going to make this $5. You can make it $4. You can make it $5. I don't really care. $4.49. You can make it $4, but the problem is 5 is easier for me to estimate, and I'm going to make it $5 times 200 people. Now the trick is, some of you still can't multiply 5 by 200 in your head, right? But there is a trick you can use. When you're multiplying by numbers that have zeros, you can just do the 5 times 2 and get 10, and then add the number of zeros onto the end, and you would have an estimation of approximately $1,000. What you need to do next after that is use that estimation to calculate the real answer. And in this case, it says use a calculator, which is great because all you have to do is pull out your calculator and see how close was I. So $4.49 multiplied by how many people? 194 people. The actual answer, this is the estimation, the actual answer is $871.06. In the second question, it says 275 times 262. My estimation is going to be 3 times 3, which is going to be an estimation of 9. That's the important part. When I take my calculator, I'll try to bring it down here. I go 2.75 multiplied by 2.62. Oh, that's not 2.62. The actual answer is 7.205. So I was off by probably 15-20% on that one. And the last one, if I make this one and this one into numbers that I can deal with, if I make this one 70 and I make this one 30, if we use that rule that we went up here, do 7 times 3 first to get 21, and then add your zeros on to get 2,100, or not dollars, 2,100 as your estimation. Your oopsie daisy. Oopsie daisy. Your calculation will be 73.9 multiplied by 25.3, and your actual calculation will be 1,869.67. Estimation, reasonably close in your calculation. Question 8. An Alaskan Malamute dog has a mass of 39 kilograms. If a Newfoundland dog has a mass of 1.8 times that amount, what is the mass of the Newfoundland? So first thing we need to do is estimate. So we're going to do 40 times 2. So my estimation is going to be about approximately 80 kilograms. That's what I'm going to estimate it as. Now when I multiply them, I'm going to drop the decimals in 1.8. I better move this over. Maybe I'll shrink this down a bit here. There we go. So I'm going to drop the decimal in 1.8. I'm going to multiply first 8 times 9, which is 72. And then I'm going to multiply by 8 by 3, which is really 30, which is 24, plus 7 is 31. Now that's not really 31, that's really 310. But we call it 31 because it's in the hundredths and the tens position, so it's 310. Now when I multiply the 1 here by 9, it's really 10. So when we do this next one, this is really 10 times 9. That 1 is really 10. And we know that when you multiply a 10 or a 20 or a 30, whatever it happens to be, by a single digit, you will never have ones. That's why we put a 0 here, because when I start this second number, it's impossible to have one, so we put a 0 in there because there won't be any. But 1 times 9 is really 10 times 9, which is 90, which is a 9 there in the tens position. And the last one is 1 times 3, which is 3. So we have 2, 10, and 7. Now, remember, we did an estimation up here. Our estimation was 80 kilograms. We have 702 with no decimal, which means the only place I can put my decimal to make sense is right there, which means the answer to my question is 70 decimal 2 kilograms. Question 10. The cost of tickets for a concert was $16.75, and the number of tickets sold for a performance was 468 tickets. How much money was collected on ticket sales? So the first thing I'm going to do is estimate. $16.75 is going to be $20. It's real easy to work with 20 bucks. And 465 is going to become 500. And action. So when I multiply these, again, we're going to follow that same rule of 2 times 5 is 10. And I have 3 zeros here. So my estimation for how much it's going to take in is going to be $10,000. Now, since $20 is more than $16.75 and $500 is more than $468, this is really what we call an overestimation. I can be guaranteed that my estimation is more than it should be. Because this is kind of one of those algorithms that I am not going to do on pencil paper, I'm going to take my calculator and go 468 times 1675, and I'm going to realize that the cost is $7,839. Okay? Now, if I do the algorithm, I'm going to do it real quick here. I'm going to drop the decimals, and I'm going to do it real quick. So 40, 56, 60, 48, 54, and 13. You get 30, 45, 36, and 40, which is 410. Is that right? I think so. And the last one is, I probably made a mistake somewhere, 20, 30, 27, and 6. Please don't make a mistake. Please don't make a mistake. 8 and 7. My estimation was 10,000, which means my decimal goes there. And thank God I did the right work. So your answer is $7,839. Question 11 says, Renata runs 5.7 kilometers a day. How far will she run in the month of January? So it kind of asks you, do you know how many days are in January? And there's 31. So an estimation will be 6 times 30, which I can do mentally because 6 times 3 is 18, plus your 0 makes it approximately an estimation of 180 kilometers. When I drop the decimal and multiply it out, I get 1767, and the only place I can put my decimal to make it approximately that much is right there. So 176.7 kilometers in the month of January is how far she will run. Question 12, an electrical contractor charges 65 bucks an hour. How much does he earn when he works for $4.75 an hour? How old is this textbook? An electrical contractor, oh, sorry, never mind. I was thinking it was $4.75, as in that's how much he made an hour. But it's 4.75 hours. Or, can anyone tell me how many minutes that is? 4 hours and how many minutes? Decimal 45 minutes. Mr. Brock is on fire. Correct. So if he works 4 hours and 45 minutes at 65 bucks an hour, how much will he get? Estimation. I'm going to use $60 multiplied by 5 hours. Therefore, I would estimate that he's going to make approximately $300. Now, because this has 3 digits and this has 2 digits, it's always easier to keep the one with the most digits on top. Because I'm dropping the decimal, I'm going to make it 475 and 65. So when I use the algorithm, it gets 5 times 5, 5 times 7, 5 times 4. I'm going to do that first. That's 25, that's 37, that's 23. Now that I go into my next number, I'm going to put a 0 down. I'm going to go 6 times 5, 6 times 7, 6 times 4. Oh, I did something wrong. Oh, I did something real wrong. Oh, whatever. That's 30. That's 45. And that's 29. My last step is to add those together to get 5, 7, 8. Is that a 9? I think so. It's 11 and 3. My estimation was $300. That will allow me to place my decimal right here, giving me a total of $318.75 is what he will make, I think. Question 13. So if we had this number times this number, we use the algorithm that got this number. We know that if we multiply the same digits but has decimals in it, we can estimate a little bit differently. This would be 3 times 90, which would mean 270 is my estimation. And the only place I can put that decimal would be right here. So I can put it like that. Same thing with the next one. 30 times 9 would be 270, which means I would place the decimal in the exact same position I placed it in the one above it. Now your parents will tell you that when you multiply this out, the algorithm they used was you count the number of decimals in both numbers. Here has one decimal place. This one has none. So altogether you have 1, which means you take from the end of it and you count off one decimal place and you put it there. In this next one, if you had 2752 and use your parents' method, here there are 2 decimal places, here there are none, which means you take your decimal and you move it 2 spots over, 1, 2, and your answer would be 27.52. With this one, you put down your digits, 2752. Your parents would say there's 1, 2 here, and there's 1 here. So you go 1, 2, 3, and your answer will be 2.752. And finally, 2752, 1 decimal place here, 1 decimal place here, and I'll put 2 using the old standard algorithm. Question 14, copy and complete the following pattern. Well, hopefully you knew the first two. 3 times 100 is 300, and 3 times 10 is 30. Now it gets a little bit complex here when I look at the next number. So 300 became 30, which became 3. 100 became 10, which became 1. The next number is really a tenth. So 3 times a tenth, or 0.1, didn't come out very well. 3 times a tenth is 0.3. And 3 times 100th is 0.03. And the last question, if you look at the pattern, really what you're doing is you're taking the decimal and you're moving it 1 spot here, and then you're moving it 1 spot more. And if I put down this, I start here, if you move it 1 spot more, you have 0.003, or 3 thousandths. Question 15, copy and complete the multiplication statement. So when I multiply by 10, what it wants you to do is it realizes that if you multiply by 10, you are simply moving the decimal 1 place to the right. So 4.65 times 10 will be 46.5. When you multiply 37, which doesn't have a decimal, by 100, you can do one of either two things. Write your 37 and add 2 zeros, which is how many zeros 100 had. Or you can think of 37 of actually having a decimal right there and moving it 2 places, 1 place, 2 places this way, but putting zeros down to hold it in place, and you end up with 3,700. And the last one, 0, 5, 8. If I put a decimal right here for the 0.58, when I multiply it by 1,000, there are 3 zeros here, which means I'm going to move it 1 spot, 2 spots, 3 spots. In order to keep in that spot out there, I need to put a 0, and my answer is 580. B says, when multiplying by a number greater than 1, should the answer be larger or smaller than the original number? When you multiply any number by a number greater than 1, you will increase the value of the number. But when you multiply by a number smaller than 1, like a tenth, like if we look back here, when I multiplied a number by a tenth, which is a number smaller than 1, I ended up with a product or an answer less than what I started with. And finally, C, write a rule. When you multiply by 10, you're going to move the decimal 1 place right. Move the decimal 1 place right. So if I multiply 3.87 by 10, my answer will be 38.7. Right? That would be the rule for multiplication by 10. For multiplication by 100 is move it 2 places. And for multiplying by 1,000, you move it 3 places. So one final example, if I have 1.384 multiplied by 1,000, my answer will be 1,384 because I move it once, twice, 3 times. Question 16. Copy and multiply each multiplication statement. So when you multiply by a tenth, we'll go back down to the rule first. Actually, we won't. We'll use a calculator. So 3 multiplied by a number less than 1 should be less than 3, and we know from before it becomes 0.3. So I'll put that there for that one. When I multiply 4.5 by 100th, I get 0.045. And when I multiply 345 thousandths by a thousandth, so 345 thousandths multiplied by a thousandth, I get 0.0000345. Okay? So when you multiply by a number less than 1, you will always have a number smaller than the original, as we said before. And your rule is easy. When you multiply a number by a tenth, what I did with my decimal is I moved it 1 place right. When I multiplied it by 100th, I moved it 2 places right. And when I multiplied by 1,000th, I moved it 1, 2, 3 places, which gave me my answer. So when you multiply by numbers that are less than 1, if you multiply it by 10th, 100th, or 1,000th, you're moving the decimal in the other direction. Question 17. What is the cost of each purchase before tax? So here, I'm really multiplying 1.99 by 5. So my estimation will be $10. My calculation, when I drop my decimals, will be 995. And the only place I can put my decimal to make it close to my estimation is right there. So the answer is $9.95. For grapefruit, $2.99 times 4. Estimation will be 3 times 4, which is approximately $12 is my estimation. Drop your decimal. Multiply it out. You get 1196. The only place I can put my decimal to approximate 12 is right there. So your answer is $11.96. Is this the last question? No. Second last. A certain golf ball has a mass of 45.4 grams. The packaging that holds 12 balls has a mass of 57.1. Estimate the total mass of the package with 12 balls. So here we will have 45. It's actually a bed mass question. 45.4 multiplied by 12 plus the packaging, which is this. Okay? So we really have a bed mass question. If I estimate this, I can make this 50 times 10. So the estimation will be 500 for this, for the weight of the balls. And I'll make this 60 because that's pretty close to it, because I can do it pretty quick. So the estimation for the sum of those two, 12 balls and the package, the mass should be about 560 grams, or a little bit more than a pound. 454 grams in a pound. When I actually do the actual math, 454 multiplied by 12 is 8, 10, 9, 4, 5, 4, 8, 4, 14, 5. Right? Since my estimation for that was 500, the actual must be 544.8. Plus the box or the package that it comes in at 57.4. Now I got to switch gears. When I add using an algorithm, I want to make sure I line up my decimals. And my final answer is 601.9 grams is what the package is going to weigh with the golf balls. My estimation was 560. I was 40 grams off, 41.9 grams off. Not too bad. And the last question, one baseball has a mass of 143.6 grams. The empty shipping box has a mass of 89.6 grams. What is the mass of the box and 8 baseballs? So the box is this. Add to that 143.6 times 8. So the first thing I'm going to do is not find out what the mass of the box is because I already know that, so I'm going to leave that alone. But I am going to find out what the product of these two is. So here I have roughly, let's make this 100 times 8. So my estimation was going to be around 800 grams. I know it's going to be more than that because I underestimated on the mass of a ball. Drop my decimals and multiply it out. The only place I can get my decimal to make it as close as I can to 800 is right here, which means the mass of the baseballs is that many grams. Now that I'm adding them together, I got to line up my decimals and add them up. And finally, I think that's the correct answer. Is that the right answer? Anyone else get that? Just me? Did we get that, Mackenzie? Did anyone else get that exact answer, or was that just me? Did I make a mistake? All right, let's use a calculator. Let's see, figure out if I made a mistake. I might have made a mistake since no one got it. 89.6 times 8 equals plus. I did make a mistake. No. Oh, I made a mistake there. Yes, I did. Sorry, I made a mistake on the multiplication. Let's try that again. So 143.6 times 8 equals plus box 1238.4. Yeah, I did have the right answer. All right, and that concludes multiplication of decimals. Yay!